Welcome back to Agent Academy. This is Mission 3, Multi-Agent Systems. My name's Scott Durow, and I'm a cloud advocate at Microsoft. In this mission, we're going to take the hiring agent you built earlier and grow it into a multi-agent system. You'll see how specialized agents can work together as a team, what makes a child agent different from connected or external agents, and how this helps you scale your solution without everything becoming difficult to manage. By the end, you'll know where each type fits, how to wire them up using common architectural patterns, and how to pass context between your agents and how to test them working together. We'll then finish with a demo of the mission where we add 2 specialist agents to our hiring agent and watch them collaborate. Multi-agent systems let you break work into focused parts. Scalability is a big reason for doing this. When each agent handles a narrow responsibility, it becomes easier to define its instructions, limit the tools they use, and test them individually, rather than trying to cram everything into one large agent. It keeps things maintainable and easier to reason. And in practice, specialist agents perform better because the model can focus on one job at a time. They're also great for team collaboration. One team can build a reusable agent and then publish it, and another team can simply connect to it. Because each agent has a single purpose, it becomes much easier to govern and access as well. Each agent gets only the tools it needs instead of handing a giant toolkit to one agent and then hoping for the best. Also, when you create connected agents, when processes change, you can then update a single agent without disturbing the rest of the systems. So, there are fundamentally 2 groups of agents that you can add to another agent in Copilot Studio: child agents or connected and external agents. A child agent is a lightweight specialist that lives inside the parent agent. The parent agent can share topics, tools, and knowledge with it, and you don't need a separate publishing lifecycle. It's perfect when you want to break down complexity inside one solution owned by one team. A connected agent is a fully independent agent with its own instructions, tools, topics, and publishing lifecycle. It must be published before another agent can call it, but the benefit is that it can be reused across multiple solutions or maintained by another team entirely. The choice usually comes down to how independent that piece of logic needs to be. There are also a few distinct architectural patterns that we can use here. The simplest is a hub and spoke architecture. One orchestrator handles user messages and autonomous triggers, and then it delegates tasks to specialist agents. This works well for either child or connected agents and is perfect for breaking down complex workflows. Another is the pipeline pattern. Agents act sequentially. One receives a message, performs some work, and then passes the result to the next agent, along with any context, of course. This can support long-running processes and even human-in-the-loop steps. A third is the collaborative pattern. Agents work simultaneously on different aspects of the same problem, interacting by performing actions that then trigger other agents. This suits more complex workflows that don't follow a straight line. For our mission, we're going to use the hub and spoke pattern. We're going to take the hiring agent and then configure it to use our orchestrator. We'll then add 2 specialist agents. The first is the application intake agent. Built as a child agent, its job is to extract structured data from resumes and store candidate information in Dataverse. It even handles duplicate detection by matching on email addresses. Because it's closely tied to the hiring agent's workflow and owned by the same team, it's an ideal child agent. The second is the interview prep agent. Built as a connected agent, it prepares interview packs, suggests questions, and helps hiring teams get ready. Since this logic might be reused in different hiring scenarios or indeed owned by a different team, a connected agent is the right choice here. Finally, we're going to test everything. We'll upload a resume and watch the hiring agent delegate to the application intake agent, then switch to the interview prep agent to match candidates to roles and prepare materials. So let's get started. Let's walk through how this multi-agent setup works in our hiring scenario. We start with the hiring agent. In the instructions, we frame it as the central orchestrator for the entire hiring process. We tell it to coordinate activities, apply reasoning, and then delegate work. That work may come from the user messages or from an autonomous trigger, and then the hiring agent will hand those tasks to the right child or connected agent. Before we build anything else, we have to adjust the settings. We set moderation to medium, and then we turn off general knowledge. That means that the agent will only use the information that we give it rather than drawing from its built-in or web-based knowledge. We save those changes and then move over to the Agents tab. Here we can add either a child agent or a connected agent. We'll start with a new child agent, and the child agent sits inside the parent agent, almost like a subcomponent with its own capabilities. The parent can delegate to it when a task matches its description, and in this case, we describe the child agent as handling resume intake. It processes incoming resumes and then stores candidate records in Dataverse. We assign it a priority so that the parent can then weigh it correctly against other topics, tools, and agents. Next, we move to the tools, and then we can give this child agent real functionality. Here, we create an agent flow. This is a bit of deterministic logic that handles uploading resume files into Dataverse. We define the inputs first. We add a file input for the PDF content, a string input for the resume name, the email address of the candidate or sender, and then the cover letter text. Depending on the channel, that cover letter may be typed by the user in M365 Copilot or pulled from an incoming email. Then we add an action to create a new row in the resumes table. When we expand the parameters, we can see every column in that table. We then must map the resume title to the name parameter and then rename the node to create resume. And we map the cover letter to and safeguard it with a quick check to truncate it if it exceeds the column length of 2,000 characters. We populate the source email address from the input. For the date, we use an expression that returns the current UTC timestamp. We've now created the Dataverse row, but we still need to upload the actual file. So we add another Dataverse action for uploading a file or image. We give it the resume name, select the correct table, and then set the row ID of the ID returned from the create action. We choose the resume PDF column and then pass in the content bytes from our input parameters. For the response from this tool, we return the generated resume number. That auto number field is then easier to work with than a GUID. Now, we add a description to help the agent understand when this tool should be used, and then we save the draft, open the Overview tab, and then give the flow a friendly name like Resume Upload and a description, then publish. Once published, the agent flow becomes available inside Copilot Studio. So we head back over to the hiring agent, open the child agent, and then go to Tools. Here we add the new agent flow as a new tool to the child agent. We give the tool a clear description so that the agent only calls it when it's needed. Now we configure the input mapping. We add custom handling for the file contents by using a formula that grabs the first attachment from system.activities. Then we map the file name the same way. Also, we must describe how to extract the cover letter style message from the user's input. If this was coming from an email, we'd pass the email body, but here the agent generates a cover letter from the chat context. We map the user email to system.user.email, which then comes from the signed-in M365 Copilot user. We save that configuration, and then this tool is now active within the child agent. Now, we refine the child agent's instructions to tell it exactly how to manage incoming resumes, candidate information, and job applications. We say that it should only use this tool if the steps match the defined process. Step 1 is to upload a resume, but only when system.activity.attachments contains exactly one file. This comes from the uploaded files in the chat context. If there's more than one, it must instruct the user to upload one at a time. We tell it to call the upload tool only once and never multiple times for a single message, and then it should output the resume number when complete. These instructions include dynamic references to the system variables and the agent flow itself. We use / to open up the selection menu, and then this gives the agent the precision it needs to follow the process with no ambiguity. Okay, let's test it. An advantage with child agents is that we don't need to publish them before testing inside the parent agent. We start a new session and upload 2 resume PDFs. The agent then should detect that there is more than one attachment and follow the instructions to request a single upload. We can see in the activity map that the hiring agent delegates to the child agent. The child agent actions are shown as sub-actions. This is very useful to be able to trace the parent-child actions in a single view. The child agent responds with "please upload one resume at a time," which is generated by the model based on the instructions we gave it. Now let's try again with just one PDF. We upload a single file, send it, and once again the hiring agent delegates to the child agent. In the trace, we can see the child agent's step-by-step actions and its rationale. You can also expand the resume upload tool call to see the inputs provided by the agent. Over in Power Apps, we use the hiring hub, and then we can see the newly created resume record. The chat also returns the resume number as expected. Now that we have a child agent working, we can add a connected agent. We create a new agent called the interview agent. We describe it as assisting with the interview process and helping hiring managers craft questions. Once the agent is created, we select a model. Here we choose GPT-5 Chat. Then we add knowledge. This is where we give it Dataverse tables related to candidate evaluation, job roles, resumes, applications, and criteria. This knowledge becomes the grounding it uses to generate interview guidance and also match to job roles. We can preview the tables to confirm the data. Again, we set moderation to medium and turn off general knowledge. File uploads stay off because the parent agent already handles that. We publish the interview agent, and this is important. Connected agents must be published before other agents can consume them. Back in the hiring agent, we add this newly published agent. We confirm the details and then configure it with a description explaining what it can handle. In this case, resumes, candidates, job roles, and evaluation criteria. After saving that setup, we can then test again. We upload a resume and then ask the hiring agent to show job roles that match the resume's criteria. The hiring agent delegates the upload step to the application intake agent just as before. But then after the upload, the hiring agent looks at the next question we've asked it, and it decides it should call the interview agent. The interview agent uses its knowledge sources to search for a matching job role, and it returns the roles along with the rationale explaining how it did the match. If we ask to list all the resumes, the hiring agent again selects the interview agent to answer this question. The connected agent queries its knowledge and then returns the list. We can even ask for something specific such as find me a resume that matches a Power Apps platform developer role. And once again, the hiring agent delegates that off to the interview agent. The connected agent evaluates the criteria and returns the best matching candidate. And in this case, it picks Taylor Test Person based on the stored resumes that we uploaded earlier. So that's mission accomplished. You now know when to use a connected agent or a child agent and how to test and monitor them. So that's all for now. Keep experimenting, keep building, and as always, keep learning. And we'll see you in the next mission of Agent Academy.